Okay, we're back. Okay, so first part of class, we learned a lot about GitHub and how to get started with this Project Zero. Let's now more slowly talk about what this Project Zero is all about. So um, there's a student class, and it has a main program that creates a student object and prints out some information about it. So the way you run the program is by executing what's called a executable jar. So let's go back into the student directory, and we can use maven w. If we run the package command, it will compile the source code, run all the tests, and build the jar file. The jar file stands for Java Archive, and that's a bunch of compiled Java code, the class files, all bundled together into a single file that's easy to reference and share around and things like that. So if you say java-jar, yep, target student summer 2019 .jar. This will run the command line, and the main method currently returns missing command line arguments. What we want to do is we want to build a program that takes some command line arguments, and so when it's run with these command line arguments, Dave, mail 3.64, algorithms, operating systems, and Java, it prints out the following. It says Dave has a GPA of 3.64, is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. The he says part is an invocation of the says method that we'll see on student shortly. So this is where we want to go. We ultimately want a program that does all of this. So let's start looking at the code that the script created to get us started, and we'll do that inside IntelliJ. So IntelliJ is an IDE, an interactive development environment. Integrated development environment that's really awesome at Java. So, oops, let's go here and say, actually, I want PSU get why don't I have date modified? There we go, date modified, way better. PSU get, there we go, summer 19. The student directory. Actually, can I just open student? Maybe I'll just open the pom.xml. So if I open the pom.xml, it'll say, aha, it's a project file. Do you want to open this project? Yes, open it as a project. And so what this will do is, I'll open a new window. IntelliJ knows all about Maven. And so the pom.xml, pom.xml is like the configuration file for Maven. And so when I open it, IntelliJ is smart enough to say, oh, Clippy comes out and says, it looks like you're trying to open up a Maven project. I'm like, yes, it is. And so then it then reads the pom.xml and then configures IntelliJ to know all about that project, where the source code is located, what the third-party libraries are. You can see it gets all these external libraries for you, all sorts of good stuff like that. So over here on the left is the project browser for Maven, and you can look in the source directory. There are 3 kinds of sources. There's main code, there's test code, and there's integration tests. And we'll be talking all about this for this project and for other projects. Probably the most interesting thing right now is the main code. There's one class called student. So this is the student class. I'm going to hide all of this so we can see it a little better. So this is Java code. Took us an hour to get here, but we finally looked at some Java code. So this is a student class that extends human. Now human is actually a class that that I wrote and is in one of my libraries. One of the things that you'll be doing in this class is that you'll be taking code that I wrote and extending it to add more functionality. So when we get to the assignment, we'll see that there's like an abstract appointment book that you'll subclass, all sorts of good stuff like that. But for this assignment, there is a human class that is, sorry, for this example, we'll say, it's not really an assignment. This example, there's a human class that is subclassed. This has a constructor, the student class has a constructor that takes 4 arguments. The name of the student, the classes that it takes is an array list of strings, a GPA that's a double, and a gender that is a stringer. And now, the human class has a says method, which you can actually navigate to from here. And currently, right now, it says all it does is it throws unsupported operation exception saying it's not implemented yet. Because when the skeleton class is created, well, it doesn't do anything yet. Similarly, the toString method isn't implemented yet, but both of these well, are overridden for the sake of example. Finally, down here is the main method. Now, in Java, a class that is public static and void main is the main method, just like in C, right? So this is where program execution from the command line starts. So I've also configured the executable jar to run the main method of this class when the jar is run. So that's why when I run java-jar with that jar file, what it prints out is missing command line arguments. If I was to project configuration can be added to Git. Don't ask me again to add those files. If I make a change, I put like letter 2 here, or number 2 here. If I then rebuild my my Maven package, it'll go through and it's smart enough to only compile the source code that's changed. It goes off and does that. It said it compiled one class, because there's only one class compiled. It runs all the tests again. And it was successful. And now if I go and run my jar, again, we'll see that now, okay, it prints missing command line arguments too. I change my source code, I rerun Maven, it rebuilds my project, runs all my tests, and now I can work with it again. This is the pattern that you're going to be doing over and over again as you build your code. Now, let's take a break from the code. So anyway, any questions about the code? You've seen Java code before. Hopefully this is familiar to you. Probably what you haven't seen before is IntelliJ, or if you have, you probably haven't seen Maven, where you're working with your projects from your command line. If you've seen all this stuff before, maybe you want to take a different class. Because boy, anyway. Okay, I'm going to undo this by reverting back to what's in version control. Go back to that.
I have a question.
Yes.
In the notes, it says that each build phase is dependent on the previous one. So it says if you run verify, it also runs package and test and compile.
Yes.
So when would you run package independent of verify?
Well, let's say I didn't want to run my integration tests just yet. Let's just say I wanted to run my unit test. I can say Maven test. Or maybe you probably just don't want to run compile because your IDE will tell you if something doesn't compile. But you can. Sort of conceptually, Maven has these different phases, and they are dependent on each other, and you can only run, you can run to any point in that build pipeline. Not build pipeline, build phases. So, your integration tests, and we'll start talking about unit tests now, or testing now. Your unit tests are meant to provide very rapid feedback. So within seconds, right, to be able to run all of your unit tests and tell you sort of like, hey, did you break anything fundamental? Your integration tests, though, are meant to do more things. And we'll see as we get further in the course, especially into Project 4, your integration tests are going to do things like start up a web server and then start up some clients and hit it and do all this crap. That takes time. Now, it might only be a minute, but still, compared to seconds, what unit tests allow you to do is make a small little change, run the unit tests, and very rapidly get feedback on whether things are happening. So that's why there are different phases.
In practice, do you do the tests without verifying separately?
Up to a point. So it's like, oh, hey, maybe I'm just writing, and actually we'll see, we'll run some, we'll write some unit tests, we'll do some test-driven development, and there we'll just run the unit tests. But at a certain point, you should be getting a little nervous. It's like, oh, I haven't run the integration tests in a while, rerun then.
Okay.
Yep. Yeah, good question. Awesome. Okay, let's watch a cheesy video. Why am I not seeing Uncle Bob? There we go. Okay, Uncle Bob. Actually, do we still have audio? Okay, this might be super loud. I don't know. Okay, Bob Martin is a well-known software engineer. Is one of the pioneers of agile software development, and he has written a number of sort of seminal books about software development. He's one of the primary instigators of the software craftsmanship movement that advocates good coding practices. He's written a book called Clean Code and Clean Coder, and he developed a series of videos based on those books. And this here is a several-minute excerpt, a 5-minute excerpt from one of those videos where he talks about test-driven development. He wears silly hats. What he goes through is he develops some code using test-driven development. Now, I guess I should explain to you what DD is. When you're approaching your work, I don't know what you were taught, but like when I was in college, there was this whole analysis phase that you went through. Back then, modeling was pretty popular. It was just before UML hit, and like the whole idea was that you drew a picture of what you were going to do, and you had flow charts and everything like that. And I think that was a holdover from back when computers were really, really, really slow, right? And so back when a compilation took, talked to my dad. He was like, "Well, we had to, make all the punch cards, and then you took them to the lab, and they ran through, and then you got your." It's like, oh my god, that sounds awful. And it was. The feedback loops were literally hours at a time, and so it was most efficient to do a whole bunch of pre-work, to draw a bunch of pictures, and sort of like do all the calculations by hand or rather run your code by hand, and then have the computer do it. Well, 50 years later, it's so much faster to let the computer do all of the work. And so really what the slowest thing is you, the human. And so the computers can do all the heavy lifting for you. And so now, instead of doing a bunch of upfront analysis or drawing a bunch of pictures or like writing the code by hand, you write the code and you see if it works. And that's sort of the mindset that informs test-driven development. So the whole idea is before you write your actual code, write some code that verifies what it's supposed to do. And what that does is it demonstrates, well, first of all, that you know what needs to be done. And that's really, really important. I mean, in my career, I've written a lot of code where I'm like, oh, I think this is what I need to do. And I get all excited about the data structures, get all excited about the implementation, thinking about the how before you really understood the what. So the thing I like about TDD is that it forces you to understand what needs to be done before you try to figure out how to do it. And actually it makes the how a lot easier when you sort of understand what the goal is and lets you work in very small chunks. And so you can evolve the how over time. Anyway, so what you'll see here in this little video is Uncle Bob is writing out a game of bowling or something of how to score a game of bowling using test-driven development.
It's time for the red-green refactor cycle, and I am in the red phase. I must write a failing unit test. All right, what test must I write that will force...
What?
Force me to write public class game? Well, I'm going to write... can create game. Game G equals new game. Oh, heavens. Thank you, ID.
Oh, wow, really?
We're all using the
Yeah.
IDE, helpful IDE. That's...
Who's downloading like the internet? Who ran Maven for the first time and is downloading like gigabytes of artifacts?
Enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test.
Do you know what refactoring is? I forgot to talk about this. You know what refactoring is? Essentially cleaning up your code. Right. So he goes, and you'll see lots of examples of it as red-green refactor. So the whole idea is you write some code that's broken. Either it doesn't compile or is a test that fails because you haven't implemented it yet. So that's the red phase. Then you go to the green phase, which is to make the test pass. which means, okay, great, you've got it working, you understand what needs to be done. And then the third phase is refactoring, where you look at your code and you look for opportunities to make it better, generally speaking. So we'll see him apply this cycle, this red-green refactor cycle over and over again.
I am passing. Lovely. Back to the red face. The next test, well, I know I want to write that roll method. All right, test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll, what should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. Ooh, but I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes, and now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
So that's the video, and happy coding.
Where did you get one of his hats?
I don't know. I'm Etsy. I'm sure there's somebody out there.
You should have a link on his site.
I bet he does.
You made that hat.
He probably made it. Yeah, I don't know.
What packet is the assertion library?
We'll talk about that. So that all comes from JUnit. And actually, that video is kind of old now, and some of the APIs and stuff are out of date. We'll show some other things. So,
It got the point across.
what? Yeah, it got the point across. Speaking of points, okay, so what did you learn from that 5 minutes?
Ready to test first?
Write your tests first. What does it mean to write your tests first? How do you feel? Maybe I'll ask a different question. How do you feel about writing your tests first? Yeah, I'm seeing a couple of these. I'm also seeing some. Why would you want to write your test first?
So you know your functionality.
So you know your functionality, so you know sort of what you need to write. Okay. Well, why write your tests afterwards? I mean, you know what you want your code to be, so why write the test first?
If you write your tests afterwards, you're depending on your use cases to find all of the problems in your code, whereas if you think about your tests up front, you're thinking about the problems that are going to come up and you're preventing them from coming.
Yeah, right. So you're basically starting from I need to do this, I need to do this. Not that here's how I do that, here's how I do that, here's how I do that. Okay. Good. Why wouldn't you want to write your tests first?
If you don't like your QA team.
If you don't like your QA team, yeah. Or you feel sorry for them, you want to give them something to, challenge, to find all the bugs.
It seems like it I guess my concern is that it would limit like creativity.
Ooh, limits creativity. Say more.
Because you have to know what you're going to do. You have to know what you expect from your code before you do it. And sometimes it's like you can come up with new things by sort of like free association coding.
Mm-hmm.
Like problem solving, you're just like trying things, and seeing what happens. And if you are trying to go at it from knowing what's going to happen first, it can maybe slow that process.
And I think that's a valid criticism. I think we've all had the experience where it's like, I know what I need to do, and it requires a lot of discipline. It can seem really slow to have to write all your tests first. And so, while maybe not every problem ought to be solved this way, I would encourage you to experiment. Right? This is that time in your career where you should be experimenting with things, like coding. But it's an opportunity to understand if this is a mindset that appeals to you. So while I can't force you to think this way in this course, this is an opportunity to explore and to see what test-driven development might mean for you. So going back to our student class, going back to our student assignment first. Ultimately, we want to get to a main method that prints out all of this stuff. And later on, I'll show you how we can write a test that does all that. But maybe we should focus on the code a little bit first. So looking at the code, what would be our first test for this class? What do we want this class to be able to do?
You might want to make sure that the GPA is a number as opposed to some kind of string or something.
Okay, right, yeah. The GPA here is a number. We'll want to validate that when it comes in from the command line. Good. What are some other things you might want to test?
The number of arguments.
Number of arguments to the command line. Okay. Meaning what?
That you have a name, a GPA, a gender, and then some list of classes.
Has all of the arguments. Okay, yep, good. Focusing off of the main method for a while, what about the class could we test?
If there's no name, everything else should be empty.
If there's no name, everything else should be
We
empty.
don't have a student.
Okay, you can't have a valid student without a name. How would you write a test for that? Let's go find out. So let's go back to the project. So we saw the student class. Here in the test directory are the unit tests for this. There's one unit test called student test. So actually, I'll just make a quick note of that. Test that you can't create a student without a name, right? That's the test case that you're talking about? Cool. Some of those other things that we want to test. When the GPA is not a valid double, what should happen?
Exit with an error.
Okay. Exit with an-
Say prompt that it needs to be a decimal number.
Okay, saying that the GPA must be a decimal. Okay, we'll come back to that. Oh, and commit number of command line arguments was another one. When there are not enough command line arguments, exit with an error. Okay.
You could also test the range of the GPA.
Oh, yeah.
It's going to be 0 to 4.
Great. Great. Okay, yeah. When GPA is less than 0,
Range error or something.
yeah, issue a range error. Okay. And then when GPA is greater than 0, oh, okay. When GPA is greater than 4, then 4.0. Sorry, what?
Can't GPA be more than 4?
Not in this class, I can't. I don't know. Do they? Boy, you kids today, great inflation. I'm telling you, back in my day, 4.0 meant. I don't know. Okay, let's say that you can't. And this is sort of the thing. That's a very good question. And in the real world, then you would have to, work with your customer to figure out if that's something that they want. If that's something desirable. This is really good. We'll do some more brainstorming for test cases later. But first this. Oh, look at this. Okay, I already have a test here in the unit test. It's called a student that's named Pat is named Pat. Okay, that's good, I guess. This tests the get name method of the student object. So when you look at that, use of var. When you have a student. And when you create a student calling the constructor, so actually I'll just do that. The constructor takes a name, an array of classes, array list of classes, GPA, and gender. So when you create one with the name, which is the name parameter, and then basically nothing interesting, we want to say that, well, when I call the getName method on this student object, I expect that the result of that getName method will be the value of this variable name. There's a pattern that I like to follow for my tests, and it's called given when then. So when you're testing something, you have a certain setup condition, right? So under some circumstances, and that's the given. So given some set of circumstances, in this case, you have a name of Pat. Given that, when I do something, when I perform some action, this is the action under test. In this case, it's I create a new student with that name. Are the lights flashing or am I having a stroke? Okay.
That was a big one, though.
Oh, man. Okay. There are the exits. Okay. Damn it. Pay your tuition, folks. Okay. I like having electricity and internet that doesn't. Oh, boy, I'm not feeling good about this. Okay, sorry. Given that you have a variable named Pat. Really? A thunderstorm?
Is that what that was?
Is that what that, oh, wow. Okay.
That makes sense.
Wow.
That was really loud.
Yeah, because like we are in the middle of the building. Okay. So. I am still recording this, right? Yeah.
I love how we don't have windows. Like I'm just.
I know this is
the
like
world could be on
this
fire.
is like the bomb shelter right here, I guess. So yay! We'll all be here programming Java during the apocalypse.
All right.
Yay! Okay, sorry. Focus, everybody. So, given that you have a student named Pat, when you create a new student object named Pat, given when then you expect something to happen. And in this case, you make an assertion saying that I expect the result of calling the getName method on the Pat object to be equal to the name I pass in. The way you can run this test is by clicking the little arrow here, or you can say, at least on the Mac, it's Control-Shift-F10. You can run it. It'll compile everything. This is why it's taking a little while the first time. And everything passed. And so IntelliJ tells you which test was run, and it's all green, and so everything passed. And so that's nice. So how would we write a test that says you can't create a student without a name? What is the given when then? Oops.
Well, it's tough because if you read the command line arguments and the first one was Java, it might just think that that person's name is Java.
As it should, right? I mean, the contract is that the first argument is the person's name. And remember, we're not quite at the command line yet. So this is something tricky. You're right. I mean, ultimately, and probably where it was natural to start, is with the command line. But let's start with the class instead. Probably, but what do you say? How do we create a student with no name? Send a null object. Okay, that's cool. So when name is null, what should happen? You're saying throw an exception? Okay. How about a null pointer exception? Okay. So let's see here. Well, our sort of, I guess we can be pedantic about it. The name is null. And so that's the given. So then student pet equals new student with the name, and then new array list, and then and then 0.0, doesn't matter. And then we expect there to be a null pointer exception. And the way you do this in JUnit, actually, I'll take a step back. So I'm using APIs from two libraries. The first is a library called JUnit, which is for unit testing in Java. This is sort of the de facto standard for unit testing. And I'm also using a bunch of methods from a library called Hamcrest, which I guess doesn't really, I can't really see that because I'm not importing a class. And all of this is described in the JUnit lecture. That gives you some very, I think, much more readable APIs for doing assertions. We'll see more assertions as we go on. Here is a simple equal to assertion. In JUnit, when you expect that some code will throw an exception, you add something to this @test annotation here called expected exception, and this will be null pointer exception .class. So what this test says is, well, when name is null, throw a null pointer exception. Okay. So now we're going to run this test.
And what in the
Yep.
in the JUnit video on your website, you said you were going to mention what the .class thing specifically is called, a reflection.
Yes. That's sort of like a week 4 or 5 concept, but for right now, let's just say that if you want to expect, if you expect an exception, you say the name exception type .class. Yeah. But yes, it's all part of the reflection API, which is a more advanced thing, which will totally be ready for in week 4 or whatever it is. So I ran my test and it failed. Aha! I am in the red, right? I don't have one of those hats, luckily, because like Cillian hats, especially that hat. So my test is failing, saying that I expected exception, null pointer exception. Okay, now I need to make it pass. How do I make it pass? Okay, so in the constructor, we need to check to see. So if name equals null, throw new null pointer exception, and let's see, I can put a message in here, right? Oops, I can. So name cannot be null. That's nice of me. Okay, I will run my tests again. And it passed. Yay! Okay, I was red, now I'm green. Let's go refactor. I don't see anything to refactor here, I guess. Maybe I can pull that into a method, but maybe I'll do that later. Here, well, I'm sort of doing the same thing Uncle Bob did, where it's like, oh, look, I've got duplicate code here. I don't know. I could create that. I could pull that onto a method. Maybe I'll do that for the sake of demonstration. So I've got essentially the same code here, where I'm creating a new student, and here where I'm creating a new student. By the way, is that large enough on the screen, or should I make it bigger? Sorry, what? Bigger? Okay, yeah, so people further away from the screen. Did that make it bigger? What the hell did I just do? Okay, sorry. View. Oh, I could go into presentation mode maybe? No, I don't want to do that.
Wait, so why doesn't it when you run that test, why does the test pass instead of giving the message that's in the constructor?
Good question. Before I answer it, can anybody else answer it? So yeah, it threw an exception. How come there wasn't, an exception was thrown? How come there wasn't an error message?
The assertion library ate it.
The JUnit testing, yeah, the test framework library, JUnit, we told it, hey, I'm expecting a null pointer exception here. And a null pointer exception was thrown. So yay, this is a good thing. Remember, exceptions are part of a contract, part of the interface for a method, just like its return value, just like its parameters. It's all part of the contract.
The test is for an exception.
And the test is for an exception, right? Which is a little weird, right? Ooh, exceptions are bad. Well, you should test to make sure that bad things happen when they're supposed to. Otherwise, you might not get the errors that you'd expect. Yeah, great question. Okay, so I see some duplicate code here. And so I'm going to turn that into a method, and rather, I want to simplify this duplicated code. So what I'm going to do is I'm going to use the refactor method, and I'm going to say extract a method, which is Command Option M, and I'm going to say this is going to be called create student named, and it says okay, great. It's going to create this signature down here. I'm going to take the name, poof. And good old IntelliJ is like, hey, I noticed that you have exactly the same code. Yes, I want to replace it there too. Yay, look at that. So now, this code, I hope is a little easier to read. I'll move it up a little bit. Oops, I'll move it up a little bit. And so now, I want to say, great, now when I create a student named Pat, I get a student named Pat. And when I try to create a student, oh, this isn't Pat anymore. Actually, I don't need this anymore. And so then I can say, actually, wait. Pat is never used. So if I say option return, remove variable Pat. And possible side effects, yeah. No, what? I guess I want to say transform. Yep, okay, great. There. And I don't know, is this name variable useful anymore? Do you think this helps or this hinders? Does it make it more readable or less readable? I don't know. What do you think?
More readable.
More readable, you like the name?
Consistent with our other tests.
It is consistent with their test. I could go either way. Ambivalent. Okay. Cool. So now I just refactored it. I got rid of some common code. I started to clean things up a little bit. I'm feeling a little better about it. Now I'm going to run all my tests again. And they all pass. Yay, look at this. And so this is how I'm exploring sort of what needs to be done. So I've got passing tests. I'm in a good place. And so what I'm going to do is I'm going to commit my code. I've made changes to 2 files. Oh, so another thing IntelliJ tells you is it has integration with GitHub. And so it knows what files you've changed, right? It can compare with what's in your local repository. So now I am going to commit these 2 files to my GitHub repository. It lets me preview changes and things like that. I can do things like, before commit, reformat the code, annoy me about to-dos and things like that. Well, I can do all sorts of neat stuff now. I'm going to commit it. I need a commit message. Sorry, this explains it. So we wrote our first unit test, and I'm going to commit it. It just committed it to my repository. Now there are no more changes there. Let's try another one. This is kind of fun. So, actually, we did this one already. Let's see here. When GPA is not a valid double, exit with an error message. Well, if we look at our student class, because we're just testing our class right now, we can't really pass in an invalid GPA. We can't pass it as a string, so we don't really have the code yet that converts it. And I want to flesh out this class a little bit more before I start focusing on my main. That'll help me sort of understand the domain. It'll make it easier for me to write the main class once I get there. Although there's a school of thought that says, oh, well, you should start with like your tests for like the outermost part of your program and work your way in. That would be a valid way of doing it. And maybe we'll do that for the next time we start one of these projects. That'll probably be a good way to approach the cones. Let's focus on these two. When GPA is less than 0, issue a range error. And then when it's greater than 0, issue a range error. So let's see here. Let's write a test for this. Oops. Public void. Let's see here. When GPA is less than 0. Issue a range error. It's probably throwing an exception, right? Is that what you meant by? I think you suggested this one, right? Like an exception. Would that be a reasonable way to issue a range error?
Sure.
Okay. Throw range error. I wonder what should we call this exception? Because I mean, we can make this very specific if we want.
The error is that it's not within a range of, of valid numbers.
Okay, so like, what is a meaningful name for that? GPA out of bounds. GPA. Okay, a GPA out of bounds exception. GPA out of bounds exception. Okay. So now, well, let's see here. So now, if I really, yeah, okay. So new student, and this is who cares what their name is. Number of classes, who cares how many classes they take. Okay, the GPA, so when it's negative, less than 0. So, oh, you know what we should probably do? Well, let's say like -1, certainly less than 0, and the gender is whatever. I'll just leave it empty because I'll pass for now. You know, I think I want to. So I wrote this here, and I'm like, you know what? I think it'd be readable because look, this is, the interesting thing is lost in this array of arguments. I think I want to turn this into a variable, and IntelliJ makes that really easy by saying refactor extract variable, and the GPA. Great, it knows it's called GPA because that was the name of the argument. IntelliJ is smart like this. So now it's got this. And so now when this happens, what should we expect? All right, GPA out of bounds exception dot class. Oops, doesn't know what this is yet because we haven't written it. That's cool. You use our friend option return. And I'll say create a class. Okay, great. I'll create a class. I want to put it in my package, but I want to put it in the source code because it's associated with the student, not the student test. I definitely want to add to Git. Thanks for asking. So IntelliJ helped me create a new class. So Uncle Bob do the same thing with the game class, right? Now, I don't know what your other professors have told you. I know that when I was a student, very early on, I was counseled. It's like, I don't know, all these newfangled tools making your life easier. Boy, back in my day, you know, we had to work for. I've moved past that, and it's like, our goal is to write software well, and we use computers to make our lives easier. So if there is a tool that can help alert me to my mistakes faster, give me faster feedback, just do the dumb grunt work, the things that I always mess up for me, that's a good thing. That helps me focus on the thing that I as a human am good at, which is writing code, because we haven't taught the computers how to write code yet. So it's okay to use these tools. Don't feel like you're cheating. Don't feel like you're not getting the most out of what you can get out of. Let's focus on the interesting things, the things that you don't know how to do already. You know how to type, right? And so let the IDE do the typing for you. Okay. Sorry.
Did you make the new class just from the?
Oh, it's an autocorrector. It's a thing. And so on the Mac, it is option return. I don't know what it is. I forget what it is. It's probably alt return on Windows. I can't remember now. Yep. So, and notice what it created. So it was smart enough to say, oh, look, GPA out of bounds extends throwable. Throwable is like the ancestor object of all exceptions. So now, okay, great. My code compiles. I will run my test. What should I expect? Fail? Why would it fail? I mean, it looks perfectly. Well, it failed. Yes. It failed because, again, it didn't throw the GPA out of bounds exception. So let's go fix that. Let's go make it green. So what should I write here? So if GPA was less than 0, throw new GPA out of bounds exception with a message of GPA cannot be less than 0. I was complaining about stuff. Right, it doesn't have that constructor yet. It cannot be applied to, that. So again, option create constructor. Here's constructor, the string. I'll call it message. And actually, I know I want to call them the super constructors. I will call the super constructor with that same message. This is all good. IntelliJ is hiding some things in yellow. We'll come back to that in the refactor stage. Okay, now let's run it again. Oh wait, it failed last time. Run. Oh, look at that. It didn't compile. You probably can't read that because it's pretty small. I apologize. It says unreported exception, GPA out of bounds exception must be caught or declared to be thrown. Oh, what is this complaining about? So, when you learned about Java, did you learn about the different kinds of exceptions? Did you learn about checked versus unchecked exceptions? Okay. In Java, there are exceptions that must be declared as part of a method signature, and then other ones that can sort of happen at any time. It's not something that you necessarily declare. There's lots of details in the lecture notes about this, but suffice it to say, this exception is one that says, hey, listen, in the constructor, if you're going to throw this exception, you must declare that you throw this exception in the signature of the student constructor. I don't want to do that because that makes things kind of messy, and exceptions are meant to be rare. So I prefer to use unchecked exceptions, which are subclasses of runtime exception. Now, if I go back to my student, everybody's happy. This is an exception that does not have to be declared in the signature of the method or constructor that may throw it. Now I'll go back to my test, run it one more time. Yay, it's green. Okay, hey, I noted there's some yellow highlights here. It says access can be package private. Because that's true, this class is not used anywhere outside of its package. And probably the same thing for this constructor, right? Well, let's fix that. So I think Alt-Enter does the same. No, what is that? Okay, it does not do the same thing as that. Just get rid of these, make it package private, so that takes away that. The default scoping in Java is package private. You can read more about that or see more about that in the lectures on the Java language. But let's see here. I don't see any warnings there. Oh, and you can tell, actually there are some warnings there. 1 weak warning found. How weak is my warning? What is it saying? Was it F2? Oh, it doesn't like this thing. It says value name is always null. That's probably not a good thing. In most programs, it's a fine thing here. So I'm not going to bother about it. Actually, can I don't report? No, okay, fine.
So
yeah.
When I created a new class from the GPA out of bounds exception from the student test.java, it put it in the IT folder.
Right. You have to be careful about where to select it. Yeah.
Okay.
Yeah. Right. Yeah. So just drag it into the source, into the package in the source folder. Yeah.
Okay.
Yeah. Unfortunately, it goes like in alphabetical order or something by default. Because it recognizes the IT folder as containing Java classes, because it does. And so then, is it getting stuffy in here? Can someone prop open the door or something without like some alarm going off? Do they turn off the air conditioning? Are there any vents in this room? Wait, I mean, there's like one way over there maybe? Oh man, great. They finally gave me a classroom that has movable desks and we're all going to suffocate. Sorry. Last year, I was in Lincoln Hall, which is the music building. And I'm like up on the 3rd floor, and as you'll recall, it was really hot last summer. And so then, and plus Lincoln Hall, I was like on the side right by the streetcar. So like I'd open the window to just fresh air, and I'm sitting here doing my lecture, going by it all the time, making a little whirring noise. Yeah, it was all over the videos. And yeah, it was just crazy. And plus, it was like a traditional classroom with like those desks that we had in high school, with like the flip over, writing tablets and stuff. We couldn't do any pair programming. And there was always like some dude playing bassoon next door, and it was just really weird. Anyway, so as soon as we can get like the lights flickering and the airflow restored, this will be a great classroom. Sorry, what was I saying? Yes, looking for things that can be cleaned up because I am in the refactoring stage. And this thing has some warnings too. Oh, it's complaining that there's some variables that aren't used. That is true. I'm not using those variables yet. So there's something that can be cleaned up here. So I think we're good. I'm going to, yeah, question, yeah.
Yeah, so you have a directory for test, and then you have a main directory as well. I'm wondering if you made a lot of separate exceptions, would you make a directory just for exceptions?
Ah, okay. So, there's two things there. In Maven, the Maven conventions are to keep your source code separate from your test code. This is a good practice, right? I mean, they have different different usages. And they are compiled with different libraries. So, for instance, you don't want your source code to be able to call JUnit. That would be really weird, right? You want to keep those separated. And so there are reasons for them to sort of be in different, separate but parallel directory hierarchies. Now, as you add more and more classes to your project, there's something called a Java package. And so this is like a namespace for the code, and the namespace is hierarchical, and you have a directory hierarchy that mirrors that. Maybe I should show you what it looks like. So actually, I'll show you here on the command line, so it may look a little bit more interesting. So if we look at the source directory here, actually, maybe this is even in the assignment. That might be the best way to look at it. Do I have that? It's in project 1, I think. We'll come back to it. Source main Java. So all of this. So source main Java is, okay, here is the main source code, and we're in the primary application source code, and the language is Java. Because in the Maven, you could have different programming languages, right? You could have C, but more likely you'd have like a different Java derivative, like Groovy, or maybe some JRuby, or maybe some Kotlin, or anyway, we'll talk more about all that kind of stuff. But you arrange things hierarchically. So here's all your Java source code. And I go into more detail on this in the Maven lecture. And then, if you notice, all of my code is in a package named this, edu pdx CS410J Whitlock. Your code will be in a package edu pdx CS410J your ID. Where when you create your projects, you give them your ID. So we all get our own package. And so here is where all my source code lives. Now, if I was adding more and more classes, it might make sense to have other packages. And so what I would do is I create another directory, maybe a subdirectory, like call it exceptions. I could do that. And that's where all my exceptions could live. I'm not going to do that right now. It doesn't quite make sense. And probably for this course, you're not going to be writing so many. Yeah, you're not going to be writing so many classes. You'll need separate packages. But certainly as you get into larger and larger object systems, when you end up having dozens of classes, there's going to be some specialization involved. Oh, great. This is the code that is all about accessing the database. This is the code that's all about implementing my REST API. Things like that, where it'll make sense for them to be in different packages. So probably not something you'll see in this course, but something that's available to you as a Java developer. Make sense? Mm-hmm. Cool. Yeah?
I'm getting an unhandled exception for the GPA bound exception still. Is there something that's special that you did that allowed that to not? It's giving me an error that's saying must be caught or declared to be thrown.
Well, that's what we were seeing a couple minutes ago, that checked versus unchecked. So is your code not compiling, or is the test running?
The test it says no. Yeah, it's an error while compiling.
Okay, so you'll have a red underline there in IntelliJ, and this is the change that we made a couple of minutes ago. To the GPA out of bounds exception to make it a runtime exception instead of a throwable.
Okay.
Yep. Nice. Playing along at home. This is cool. So anyway, I'm going to run all my tests, which I can also do from over here. I'm going to say run student tests. Yay! And you know what? I'm also going to make sure that everything still runs from Maven. So now I'm going to say, if I say Maven W tests. Can't remember what it's called.
Do you have to package first?
Actually, no, I don't. Package builds the jar file. I need to build the jar file to run my test. I just need to compile the code. Good question, though. Good, that's all happy. I'm actually, just for fair measure, since it's pretty fast, I'll just run Maven verify, which will run not only my unit test, but also my integration test, which we haven't talked about yet. And we might not get until, it's only 7:35. We've got, what, another 2.5 hours or something? Yeah, okay, we're getting there. And we're probably coming up on a break, too, because it's been a while. Okay, well, all of that's happy. Okay. Cool. Okay, well, so then let's go back to our version control. Let's check some stuff in. I now have 3 files that I've changed, including my newly added GPA. I'm going to check all of that in by using commit. Okay. Okay, well, I'm just going to say when the GPA is less than 0, throw an exception. So I'm going to commit, but I'm not going to commit. I'm going to commit and push back to GitHub. And because all this stuff is integrated into IntelliJ, once it's done pushing, and by the way, I've configured IntelliJ to like know what my GitHub key is and all that kind of stuff. Now when I go back to my repository here, great, I got the latest code. So now all this is being pushed up to GitHub. Okay, where to go next? We can probably all guess how to write the next test, so I'm just going to do that quickly, just so you can see it one more time, and then we'll take a break. And I'll try to talk a little bit less. Actually, I don't need this comment anymore. Actually, I'm just going to duplicate this, make it easy. So when GPA is greater than 4, oops, greater than 4, through a GPA bounds exception. So now I'm going to have it be 4.1. Going to run it. I'm going to start using keyboard shortcuts, but I have IntelliJ configured to pop up when I hit a keyboard shortcut, I have a special plugin to IntelliJ that pops up. Oh, here's what that meant for all of your benefits, so you can learn the keyboard shortcuts. Which, by the way, learn the keyboard shortcuts for whatever tools you're using. You will be faster if you take the time to learn how to use the keyboard shortcuts. No matter what piece of software it is, moving your mouse and clicking is slow, and I'm thinking it's bad for you. All of this like mouse movement. I mean, okay, complete aside here. Now that I am multiple decades into my career and sort of approaching midlife, let's be honest, it's really interesting. One of the things I'm noticing more and more about myself and the people around me sort of that are in my age cohort is that there's some physical tolls of this job. All the sitting that we do, all the repetitive, I mean, all the stuff about like carpal tunnel and stuff like that, that is serious. And to us, I mean, this is like, you know, a basketball player tearing their ACL, or these are like career-limiting and career-ending moves. So take care of yourself. And it seems silly, but it's the kind of thing where it's like, wow, I think about these people that have been very, you know, sedentary and sort of doing the same thing for like, you know, 20 plus years. It takes a toll. So something to be aware of, and something that if things start hurting or whatever, see your doctor. It's in your own best interest, it's in your employer's best interest to make sure that you're healthy and can do your job physically in addition to mentally. Anyway, a little public service announcement there. Don't know where that came from. Okay, I ran my test and it failed because it expected a GPA out of bounds exception, didn't get one, and so now I'll go implement it. And so now, let's see here. I like my else statements. If GPA is greater than 4.0, then throw this guy cannot be more than 0.
Is that cleaner code?
Thank you. Sorry, what was that?
Is that cleaner code than putting in the if statement doing like GPA less than 0 or greater than, or GPA greater than 4?
Yeah, you could. I mean, this way you can have different error messages. I don't know. We clean it up later. I don't know. Yeah. Yay! Everything passes. Okay. And that was kind of silly. Okay. Let's pause again. Let's take another 10 minutes back at 7:50. I want to start right at 7:50 though, because we're still going here. We still got a ways to go.